Hello everyone, welcome to this first devlog of my Metroidvania style game. So the game is currently looking like this, and this will be like the first devlog where I just go through what the tiny things I have in here, and we will look at the code and how everything is set up. So I have this little funny game here, and you can walk around, you can jump around and climb around these things. Jump over here and jump here, and I'm currently sort of experimenting with skills and stuff. So I have one skill I have is like you see they have this gap that is too small to get through. So what I have here is that you can press a key and then your head pops off and then you can roll under. And I'm trying to experiment with these different funny skills to find nice synergies for like skills you could use together and stuff. So another skill I was playing with today was the magical nose that goes out like this. And currently this one sort of gets stuck to a wall and then you get sucked there. I'm thinking that maybe this skill I will change so that you get maybe you more used for like poking buttons or something in the world. We'll see. And I also want to add like just experiment with more skills to like that might have I'm gonna try initially to have like funny things related to the character itself. The next skill I was thinking of was maybe you can shoot out your legs like harpoons and attach to the ceiling or something like that. Just play around a bit with strange stuff that might seem a bit morbid, but it's only 2 colors like you see, so even if it's morbid it doesn't feel like it. So if you watched any of the previous streams, you know I was just playing around with graphics, and then finally I was like, let's just try having just one background color, one foreground color, and it's actually pretty fun to play around with. I like from like for example animating this thing was pretty easy, and it's like, you know, inspired by games maybe like Obra Dinn, for example. In Obra Dinn you have only like it's a 1-bit color game. That game uses dithering a lot. Maybe I will try to do something cleaner. We'll see where it ends up. Right now I just have this very basic tile set and this basic animations. So that's sort of like, there's not that much to the game right now. You have this little world you can run around in. You can press F2 and then it jumps into this editor mode where you can place blocks and then you can resume playing, and then I can't reach that one, but you could, and there's a couple of different blocks you can cycle through. Right, so I could place stuff like this, like that, you know. And a funny thing with only having 2 colors is that I don't need to, you know, usually when you have like, usually maybe you have a background color that you try to, maybe you put a sky color, and then maybe you also want some other color that's like inside the ground, and then you have to, you know, fill out that, like you have to fill out that void that's sort of like supposed to be the dark inside of the ground. When you have only 2 colors, the only thing you need to do is clear the whole screen in one color, and then just you can draw all these things on top here, and these things don't even need to have this green as background color. They can just be transparent where they want the green to shine through. So you only actually need textures or whatever you have that use one color plus transparency to get. So it's pretty, but we'll look at all that stuff as we go through this. So today I mean now I've showed like just how to, what's in there right now, but what I want to do now is just, since this is the first devlog, I will go through all the code from where the program starts out to the gameplay stuff, and we'll look at all those things, and also how I'm using like an atlas texture here. I will show that little tool I made for baking that and all that. If you are a patron, then there is a link in the description of this video to the code, which patrons. Some patrons have access to the ones that are on the tier high enough to get source code for my projects. But anyways, let's do that. Let's start. Or first, I'm just gonna say hello to chat. Hello, David Dash. Chameleon is happy because they caught a live stream. Welcome. The spiked roof looks like it would be instant F to jump into. Yeah, I might have to rework that one a little bit. We'll see. This is my first placeholder graphics, really. Anyways, so let's take a step back and we go to so this game is written in Odin programming language, right? And uses Raylib for rendering. Raylib is a library written in C, but Odin comes with bindings, so you can quickly get set up with all that. I use a template that I've made myself that allows you to quickly get up and running with Odin, Raylib, and hot reload, so that you can hot reload gameplay code as the game is playing. And before, I can just to give an idea of what that means, I can quickly show the hot reload, how it works in action before we go to the main proc and show how the whole program is held together. So if I go to draw here, for example, here is my clear background thingy. And we could change the color here to some super ugly red color. Recompile, and as the game is running, everything just gets red. And there you see also that all my textures have alpha. I don't put that green color anywhere. It's all just these things with transparency. So actually changing that background color also changed the inside and the eyes of this one. So you see that it's just one color plus alpha, really. Let's change that back before your eyes bleed. Right. So, like I said, I have this template that you can find in the description of this video, and this template provides the hot reload functionality and just some super simple example program. So let's start at the main procedure and work ourselves all the way to the gameplay code, and see what I put together here. So all programs in Odin start with the main procedure. So the program you start on this line here. I won't go through exactly everything because some things are maybe less interesting. Here we set up. Here you say that anytime you use the logger, it should go to the console, which is this thing here. That's not so interesting. What I'm doing here is setting up a tracking allocator. What that does is that everything, all the dynamic allocations that use the default allocator in my program, if I forget to deallocate any memory, because Odin uses that manual memory management. So if I forget to deallocate anything that uses this default allocator, that is this one, that is passed around automatically to everything, then at the end of the program it will warn me about which allocations were not accounted for, which ones you didn't free. And that's just at the end of main here, you have it just checks somewhere here, reset tracking allocator, this procedure here, which is defined up here. This one just checks the tracking allocator, goes through the whole allocation map and says if there's anything left in here, that means you leaked memory. Amex says that they didn't realize that Odin came with a tracking allocator. Yeah, it's in the standard library. You just need to import core mem, and this is also all this stuff here. Everything in this main hotreload.odin. This is available in the template that's linked in the description. So the program starts here, sets up the tracking allocator. And what it does then is that it, this line here opens the window, so this thing here, and then it tells this game API thingy here says that I want to initialize the game, sort of set up all the stuff for the game. And what that thing does is that it creates a blob of memory that can be reused between hot reloads. So that's sort of how the hot reload works. It will have a blob of memory with all the game state inside, and whenever you recompile the game, a new game DLL is outputted, and it sort of loads that one and starts feeding that one the same memory as you had for the previous game DLL. And by the way, this game API thing is initialized up here using this load game API procedure. What that one does is, if we look up here, this one returns to this. You can have multiple return values in Odin, so this one returns the game API and OK if everything went OK. And so this thing just fetches the game DLL, or on other platforms the DLL extension is different. If on Linux, like you have DLL, dlib, and .so depending on if you're Windows, Linux, or Mac OS. So it checks when that one was last written to. That's the first thing it does, and then it copies the whole game DLL to a new location. The reason it copies is that if it loads the game DLL directly, then it whenever your Odin compiler, whenever I'm in here and pressing F7, that DLL will be locked because it's loaded by the game, so it can't write to it. So that's why it copies it and then loads the copy instead. So that this does all that. And then here is a cool little procedure that's built into Odin, initialize symbol. So what this thing does is that it takes this API struct here, yeah. It using reflection looks through this one and matches up the names of these fields in here to the names of the procedures in my game DLL, and I will show you those procedures very soon. Well, we can look at one right away. Like, for example, init is a procedure that takes no parameters and returns nothing. So if I go to game.odin here and find init, and it's called game_init, then this is the thing that sets up my game memory and sort of gets the game going right. So the reason it can still, even though this has game_ in front, it can still match up this init thing, and it does that by, you just tell initialize symbols that all the procedures will be prefixed by game_. So that way I can be like, this is actually game init, this is game update, this is game shutdown, this is game memory, like all these procedures will just be mapped up to that. So, so this thing just matches up all those procedures in the game DLL with the fields of this struct, and then it might fail, so then it just says something failed, and then it records the API version, which is just a number 0, 1, 2, 3, 4, 5 for every time I reload the DLL write. And then we have the modification time here, which is the thing that I took out up here so that it can compare this later. If the game DLL has been changed, that means that the modification dates between the new one and the current one should be different. So that's how we check if we need to do a hot reload. We check the modified date. So that's what load game API does. So this thing then, like I said, we already talked a bit about this. Here you see that this is the game API version, which is the version that is fed in there. It inits the window, and this, like I said, init will give you it will create the game memory here, which is just a struct that has some stuff in it, right? And then this is the main loop here. In Odin there are no while loops and stuff. There's only for loops, and if you just have a for loop with a boolean like this, like if it's just for and then a single bool, it's the same thing as a while loop, right? So it does all this. Well, it starts up this is like the main loop as long as the window is open, and in my case I've said that the game API tells you if the window closed. That's just how I've done it, because this file here is mostly agnostic to which windowing API you use. So I use Raylib to manage my window. So this one doesn't really know. I think there might be one or two Raylib things in here. I'm not sure. I don't remember. But I try to not use Raylib stuff in this hot reload thing because that's more up to the game to open a window and say, did the window close? So this update returns false if the window closed. And this update is your main update. This is where all your frame by frame game logic and rendering, everything happens in here. It's up to you to how you split things up inside game API.update. And we can, I mean, it's this, for me, it looks like this. We'll look at all this code later, but it's just game API update returns a bool. And that bool is returned at the end here. It's just if the not window should close, which is true if the window should not close. And the hot reload itself is done by, it takes the game.dll here, and it checks the last write time for it. And then if it was able to properly check the file write time and the time is different on the one on the game currently on disk from the one we have loaded, then we say reload true. And then down here we do the actual reload. We don't need to look at this thing so much. This is the actual hot reload stuff. So this one just like, it tells the game API, please give me a pointer to your current memory. So this memory thing, it does nothing fancy. You see, this is what game API.memory does. It returns this global memory thingy. And that global memory thingy is just the one we created when we ran init, right? Nothing weird. So game API.memory, this fetches the pointer to that one. And then it just says that the new, it just changes the game API to be a new API here. And by the way, yeah, of course, we up here we loaded, like the first thing we do when we want to reload it, that we load a new game API. So, and if it was able to properly load it, everything went fine, then we do these things, right? So down here we have stuff like it fetches the memory for the game, it fetches the pointer for the game memory, and then it swaps out the API to the new API it loaded, and then it tells that API, hey, I just hot reloaded, and here is your new memory. Because this new DLL, you know, all this, the memory inside the new DLL will be all, that's just like the point, this gmem pointer here, that's just a global variable, right? It's somewhere, this here is just a global variable, right? So when it loads a new DLL, and then that one will have all its global state be, you know, zeroed out, or some kind of default values. So in that case, this will be a null pointer. So that's why it then runs hot reloaded here, so on the new API. So it can take that game memory here. So it just sets gmem to this pointer we feed in here. And then it does some extra stuff. Essentially, anything related to global state you might want to reinitialize here, because any global variables will be dead after hot reload. So you should maybe avoid having many global variables. But if you want some, then you need to reset them in here. And that's sort of this proc here, for example, is called here, because that one sets up some global variables used by the editor I showed, where you can place the tiles and stuff, this stuff. And yeah, so that's just what it does. This thing up here, so this is the hot reload stuff. It doesn't, by the way, unload the game API, the old one. It just puts it on a pile, says old game APIs, because there might be code in your game memory that, for example, maybe it used a string literal somewhere, and that string, if it's a string literal, that string actually exists inside the old game DLL, so it can't really unload it. But this hot reloading is only for development purposes. So, and the game DLL doesn't take much space, so it's fine to keep them around, really. However, if hot reload works fine as long as your memory layout doesn't change too much. There are some people who are trying to figure out ways around it, but the important thing about hot reload is that you can tweak gameplay code as it is, as you write it. Maybe tweak subtleties of an algorithm, or maybe tweak UI, push it around pixel by pixel, all those things that requires like 50 restarts of your game otherwise. That's where it's good. And in those cases, usually you're just changing procedure code. You're not adding and removing fields from a struct. Because if you change the layout here, if I add hello int here, then all these were pushed down 4 bytes. Or 8 bytes, depending on alignment. And in that case, if you're just reusing the same memory, then that memory, in the old memory, suddenly this value will be somewhere in here, right? So that's not good. So I check here if the memory size, which is just the size of this struct, I check here, are those different in the new game API than the old one? In that case, I do a hard reset, which just means that I tell the whole game API to just shut down, throw away all the memory, reset the tracking allocators, unload all the old game APIs, because we are just starting over. It's essentially like restarting the whole program, but without having to restart the program. But this is just a safety measure, because you might, just because otherwise, if you just continue running, in this case, you are quite likely to have weird errors or crash. I also have a button called force restart. You can ask the game API if you want a force restart. In my case, that just means, did you press F6? That's what it does. Okay. I already talked about the tracking allocator. And yeah, and then it just, after the main loop finishes here, it just checks the tracking allocator and just does some simple shutdown thing. It's not that interesting, so we can ignore that. Archie Murray says, I just looked at your template. I didn't realize that you were linking Raylib as a DLL file. It had been causing me crashes as soon as the DLL tries to use Raylib functions, as they didn't share context. Yeah, so what happens there is actually just like, when you hot reload, I have to run, when I hot reload in my DLL, in my game DLL, I have to run, I have to update this global variable here, right, with my pointer to my game memory. Raylib itself uses global variables to keep its internal state. There is like when you open a window and do things inside Raylib, it actually has some state that lives on a global variable inside Raylib. And if you statically link it, then all that Raylib stuff will be inside your game DLL. And if it's inside your game DLL, when you load a new one, you have a copy of all that Raylib stuff, right? That has its own global variables. So when you load a new DLL, it is as if window init, open window, and all the Raylib setup, as if that never happened. Because each game DLL will have its own statically linked version of Raylib. So you can't statically link Raylib into your game DLL for that reason. So when you use the Raylib, you use dynamically link Raylib as a DLL instead, then your main program will just fetch that one once and then just keep that one alive. Even if it throws out your game DLL, the main program, which is a game exe plus a game DLL plus a Raylib DLL, it will just swap out the game stuff, but the DLL with Raylib stuff will live on the side with all its global states. So that's sort of why it works out fine. Let's just also quickly look at the structure of this. Maybe I can pop up the file explorer here. So here is the game exe. The game exe is built from the main hot reload folder here. The main hot reload folder only contains this file we looked at, main hot reload. This is just the exe that loads DLLs and all that funny stuff, right? So that one, it can compile separately, and then from all the Odin files here, inside just the root of my Metroidvania-ish folder, this is the stuff that is compiled into game.dll. So whenever I hit F7 here inside Sublime, then it recompiles the DLL, and like I showed, we can, for example, clear the background color, press F7, and it recompiles. That was a sad, not so big change. So that's essentially what happens when you hot reload that. Anyways, so you have your game exe and game DLL, and the way these are built, comes with the template. I provide these batch and shell scripts. On Windows, it would be a batch script. So, for example, build hot reload. This is what is bound to F7 in my Sublime. So we can ignore these things. We'll talk about them later. But here it builds the game DLL from the contents of the current folder, Odin build dot. It takes all the stuff in here in the root, and that will be outputted as a DLL here, right? And then what it does here is actually that it checks, is the game.exe already running? If it is already running, then it quits here, because it doesn't. You don't want it to try to, like, if the game is already running, you only want to do the build game DLL step. You don't want to try to rebuild the game exe, because that won't work, because that one is running. It's locked. It's not gonna work. And yeah, but if it's not running, then it builds the main hot reload file here as well, and outputs that a game.exe. And then I think my build system in Sublime also, which is down here. Yeah, you see it runs when I do my build, it runs this batch file, and then this and only runs the rest if that has a that stuff only runs if this one returned error code 0. So, which happens if everything went fine, if it came to down here. So that's sort of how the whole hot reload stuff is sort of held together. It's just a program compiled from the main hot reload stuff, from the stuff in main hot reload, and then a DLL compiled from the stuff in the root. Some people have said that maybe you should have a subfolder for the source files here. It's a bit chaotic to say. For me, that's something you can do on a per project basis, I feel like how you want to organize it. I want to impose the minimum amount of organization in the template. I'm thinking myself of maybe moving this stuff into a subdirectory, but that requires a bit more from the build script, because suddenly you must have a build folder and copy resources around, like textures and stuff. So, you know. Hello, Teavias. Teavias says, Odin is too hard for me. I'm staying with CPP. I would say it's actually easier than C++. There's like the language is much smaller, so it's probably a lot easier once you get past the initial. Maybe there's less things to Google. That makes it a bit harder actually to learn, because it's newer. But the language itself is easier. You're gonna people usually say that there's almost no one on this planet who knows all of C++, because you can program it in so many different ways. But there are, but something like Odin, you can learn almost all of it quite quickly, because it really attempts to be tiny. Okay, so we have looked at the main hot reload stuff. So now we can, let's look, we already looked at the init procedure. So like I said, everything in game API is the stuff in here in the game.odin file. So we have game init. Game init here sets up the pointer of the new game memory, which is the global pointer where I store all my game state. And then each frame it runs update. So we can talk a bit about my atlasing stuff later maybe, but let's just now go to update here, and we can look at the basic game loop here first, because I think that's interesting from like how does the game actually work. So the game update thingy, I have one thing that's auto reload up here. We can talk about that later too, because that's related to auto reloading based on changes to like assets, like textures. But these things are just here to sort of enable the editor and enable auto reload of assets and some debug drawing. If we're editing, then we run this code. But so if we're not editing, then we get to down here. So this is sort of the main game stuff, right? And what I do here is sort of a proper fixed step update. Actually, there's a person in the Odin community, Jakub. He just released a nice blog post about fixed time step updates. I will link it in the chat and later in the video description, because it's not there right now, but it also has Odin code and all that stuff. But essentially what you want to do here is, so this is my this game update is run every frame of the game, but what I do here is that I run this loop here that might tick the game, essentially update the game multiple times in one frame, and it does it using a fixed time step. So what that means is that if we go to something like the tick procedure here, then we see that it uses, like everything in here uses this dt thing, and this dt is just a global constant that is 1/60. That's just 60 FPS, 60 Hertz. That's my fixed time step update frequency. This so what it does here is it has this accumulator up here. So every frame, Raylib says this is how long the previous frame took, which might be like, maybe it took, say that it took 17 milliseconds the previous frame. Then it will add it to the accumulator, and dt in this case, like 1/60 is roughly 16 milliseconds. Then this loop here will run once, because accumulated time is bigger than dt, like 17 milliseconds bigger than 16 milliseconds. It has one tick, and this tick uses this dt fixed at 16 milliseconds. And then it decrements this accumulated time by dt. Then it goes again, and when it comes back here, it will be like 1 millisecond left in it. So then it won't be able to run this once more. So then it goes down here, and then it draws the game. That's the basics of it, sort of. And the reason you do this is that, for example, like your game will behave much more predictable if you just use rl.getFrameTime, which is Raylib's getFrame, like how long was the previous time. If you always multiply by that, then things will usually look like they are okay. But suddenly you get a stall in the frame rate. Maybe you get 300 milliseconds for some reason. Maybe like it can be any reason. Like just moving around the window like this actually pauses your game in a way that you might get a giant spike when you release it. But it can also happen for other reasons, that you just have uneven frame rate. And then since if your character then moves using this delta time. Then you might fall through the ground, fall through walls and all that stuff. So by doing something like this, then you have predictable. It will always tick with the exact same amount, and it will do it as many times as this thing up here says that it should. And sometimes it won't tick at all, because sometimes you will get like 15 milliseconds and I want this to be 16, then it has to wait until the next frame to get a bit more in the accumulator, so it can actually run the tick. There is some stuff with input here that I get the input. This is just get input here is like, are we moving left? Like it's just for walking around, and then you have space. If you press space, it jumps, and then I have bound up this A and S. The S is the tongue, or as I call it, the nose, and A is for separating like that. These things just return this input struct, right? The funny thing here is that input is actually a global variable, so it first makes a copy of the old input state. You see the input is somewhere here. Yeah, it's just a global variable here, and it makes a copy of the old one, and then it gets a new one. And then for some things like the jump and separate and the tongue thing here, it actually caches them until you can actually have enough time in the accumulator to do a single tick. Otherwise, if you have a frame where you got 15 milliseconds in the accumulator, so this couldn't run, but that was the specific frame where someone pressed space. If you only check that one frame, and then the next frame, oh, now we have enough time in the accumulator to run this loop here, right? Then that space, like if you just always get the latest input for this specific frame, then that state, that sort of input state will be lost because you missed it. You cannot miss stuff. There's lots of different funny ways to solve this. I just, for things that like for the arrow keys for walking, I just check if they're held down. For that, I don't cache the old stuff. And Jakub talks a lot about this in the article I linked. He does it in a slightly more fancy way. We'll see where I land with this, but it's just something to keep in mind when you do fixed frame rate updates, that you must because when you reach end drawing down here, right, then it will reset your input state essentially. So in that case, you might lose, like it did, this will fetch new input state inside Raylib here. So then you might lose stuff, right? Another thing you should, like the last piece of this fixed step update is that you can interpolate. So what you do then is that you have the old game state and the new game state, like the old position of the player. You can just talk about the position of the player to make it simpler. You can have the old position of the player and the current one, so the previous and the current one, and then you just have this value here, accumulated time divided by dt. So dt is accumulated time at this point will always be smaller than dt due to this stuff here. So this will be a value between 0 and 1, which can be used to blend. So you can just blend position from the previous time the tick ran to the new time. I haven't implemented that yet. That's why it looks like some stuff is missing here. So my game is doing the correct, it's doing the correct stuff here, but it's not doing the interpolation properly. It just feeds this in, and this isn't used into draw here. So sometimes it can look a bit choppy because it is, for example, those times when it is maybe it gets only 15 milliseconds in the accumulator here, then and this is 60 milliseconds, then it cannot get there. So, but I will try to fix that. But we can look now at what draw does. So draw takes a camera, and the camera in this case we can look at that first. Actually, the camera is just a thingy that zooms the game. So I have a pixel window height, which is 180. So if you have a 16 by 9 aspect ratio, this means that you will have 320 by 180 pixels is what I aim for. But if you make it narrower like this, then you will see more to the sides. But the amount you see from top to bottom will always be the same. You see this thing here sort of stays where it is. You see the same amount of stuff top to bottom. Another way to do this is to have a fixed, like you have 69 and then you render black bars if you really want to keep that's what I did in Cat and Onion, my previous game. But in this case, maybe I'll try to go for using a more dynamic thing like this. So the game camera just sets the zoom of the height of the window in pixels, because this window, you know, now it's bigger, now it's smaller. So it takes that height, divides it by the pixel window height. And that way it keeps the height in pixels constant, because it zooms the view in a bit just to make sure that everything fits perfectly. Other ways to do this is to keep, you can also have if you want it more like super pixel perfect, then you can also have a render target that is 320 by 180, render into that, and then keep everything perfectly on the pixel grid. Then you have pixel perfect rendering. Games like Animal Well do this. Animal Well uses a 320 by 180 back buffer to render into, and the whole game just has nothing more. But the one thing I do that you might see here, that I'm no purist when it comes to these things. So for example, I press A and then it rolls, and this just rotates the head, and you see this is not axis aligned. So I'm not a purist with this thing. I think I can do more fun, silly things with gameplay if I allow myself a bit of freedom with these things. You can see this in Animal Well, for example. There are these enemies in Animal Well that walk up edges, and then they're supposed to turn around and walk, like they can walk up like this, and then they turn around and walk to the right. When they pass this corner, they just snap, because it would need quite an complicated animation to do maybe there was no time, I don't know, but because that whole game flows very nicely. But the only time I see it sort of snap a lot is those sort of funny creatures that snap along the corners, because if you use a 320 by 180 render target, you have a tiny resolution, and if you just rotate things in there, if you just rotate your pixel perfect stuff, it will look like absolute bad. So rotating things you can only really do if you render in an actual high resolution. So that's the camera. It's a zoom, and then it targets the controlled entity essentially, plus some offsets and some because you see it sort of smoothly moves the camera sometimes up and down here, and that's this stuff here. It moves the camera position. Why? We'll see that later. But so it's essentially the player position fixed on the player plus some silly offset that doesn't matter, and then this thing here says where is the middle of the camera. I say the middle of the camera is in the middle of the screen. That's why it says W and H here like that. So if we go back then to game update, so into draw you feed the camera and this thing, the blend factor here, that I should use to blend my old position with my next position for the player and for the camera and all that, but I currently don't. So it's not used. So inside draw, I clear the background. We saw me fiddle around with that to show the hot reload, like this. And then I do rl.beginmode 2D. This thing is what tells Raylib to use this camera. So this is essentially moves everything in the world so that it is where the camera should be looking. And currently this is like early prototype stuff, so I don't have any sort of performance optimizations in here. Like currently I render all the tiles in the world. So this is what this does. 4T in game gmem.tiles. Gmem.tiles is both the thing you edit from the editor when you go like this, and it just fetches the tile world position, because these tiles have a position that is an integer, so it's like a grid. And then it just takes that and multiplies it by the tile size, which is 8 by 8 pixels. And then it draws it. And what the thing it draws using, so usually in this case it uses an atlas, right? So it just says draw this tile at this position. This is the texture, this is the rectangle in the texture, the atlas rectangle you should use to draw, and draw it at this position. So what is this stuff? Let's take a little detour and look at the atlas stuff now that we have something that uses it. So the atlas rect here is comes from atlas tiles. Atlas tiles lives in atlas.odin. Where is atlas.odin? It is up here. Atlas tiles is this thing here. It takes a tile ID, which is one of these, and then it says a rectangle. So this is a position, position in X, Y, and then size. And you see all these are 8 by 8. That's because they're tiles, right? And this file is not handwritten. This is generated by my Atlas builder. So let's look at what the Atlas builder does and what it outputs. So one thing it outputs is this file. This file has all my textures in the game. So I can just talk about textures in the code. These are the textures, like I have a folder here called textures, and in here we have the player, we have the player's body, the head, the animation for detaching the head like that, and then we have my tile set. These are the textures. So these here we have in here are both animation frames and all the ones with a number at the end is animation frames, and these are because head and body doesn't have animation frames, while the player animation, which is the walk cycle, has what is silly animation, and then of course the detached head animation has many frames. So you have all that. So I will show you how these get split out a bit into sort of because if we open player head detach here and look here, then this is, you see, this is 14 frames. So what it does is that it notices that this asprite file, so this Atlas builder works directly with asprite file. I don't have to export in between. So it sees that it has frames, and it splits that up into separate textures. But in this case, textures are just rectangles, because we will make everything into one atlas, where a texture is just where in the atlas do we look. And the atlas, by the way, it looks like this. Maybe I don't have a super good way to show this, but I can maybe zoom in here. So you see here, these are the different frames of the animation. These are the tiles here, and here's the head, and I think also these are the walk cycle frames here. So that's the whole atlas currently. But you see, that's all in one texture, and a texture then is only like which rectangle in the atlas should we use. So there's two things here. There's both atlas textures, and that's these guys. These are both all the textures that both the separate textures, but also the animation frames. So these are the head and the body textures, and they say that they all are this rectangle, and then there's all they're all this rectangle here, and then there's all animation frames. Which rectangle are they on? Then there's some other stuff like the animation frame duration. Even if it's not animation, they still get set to some default value. But a nice thing about this is that if I work in asprite and I can set specific on a frame, I can set a duration like this. So I can make one frame longer, and that will actually be exported into here. And then there's an offset here because the asprite tells you how, like the asprite file format will tell you how, like it won't save like empty pixels. What that means is that if we actually, there's a better way to look at the ready atlas. So the ready atlas is is here. You zoom in an sprite, I realized. So I can also put in a background just to make things clearer. So in this case, what was I thinking here? That the offset is because you see these are tightly packed. There is no wasted space, because if you look at the detach animation for this frame, there's lots of space above it here, but that frame is here, and you see that space above is not there. So that information about how much was this one offset from where it should be within the animation, that stuff lives in this offset thingy here, right? So that's why all these frames have different offsets, because there's different, if you look at this, there's different amount of empty space measured from the top here. So you see these offsets here are not all the same for all the head detach frames. So how does that's just the textures. And we were looking also at the Atlas tiles here, which is, I showed this a bit. So there's an Atlas ID. This is just pre-populated to be like, this is tiles at 0, at Y position 0, X 0. So that's, if we open I can open the tile set here. Then this is tile 0, this is Y0, X0, this is Y0, X1, etc, etc. So it's just these, and it's 10 by 10, and you can configure in the Atlas builder how wide you want your tile set to be. So we'll look at that shortly. But so you have all these. It just pre-generates these so that you have all of them, so that because you might save these tile IDs to serialized data. For example, the world in my game is world.json, and this one uses the wrong. So in this case, you see tile is 0 here. Here tile is 4, and this is the numeric, the integer representation of this tile ID. So this is 0, 1, 2, 3, 4. This is 4, etc. So it's just the order they appear in this in enum. And that's important, that's stable, so that your data, that's why, even though I don't have a massive amount of tiles in my tile set already, this thing here is pre-generated to have a lot of things in there, so that things don't move around. And for the ones that actually appeared, for the data that the Atlas builder actually had, for the ones that there was actually there was actually any pixels there, like these first 10, it will say where in the Atlas did these end up, right? And that's Atlas style. So that's why this thing here gets a rectangle and then draws using gmem.atlas, and gmem.atlas in init is it just loads the Atlas file name, and the Atlas file name is defined in atlas.odin to atlas.png. So that way it can draw all the things in the game with one texture. And the Atlas builder also supports fonts, but I don't have a font yet. But they should work out. I've used that before. And these things, the Atlas builder, for example, I did some prototypes in the spring, and I did the Atlas builder then, and I tweaked it a bit. So many of the things I'm using are actually things that came out of things that I did earlier this year. Also, when you hot reload, it actually unloads the Atlas and reloads a new one, because during the hot reload it might actually have rebuilt the Atlas, because there might also be, you might hot reload to get in new texture data also. So the where's the Atlas? And finally, just before I show how the Atlas builder sort of kind of works, we have the Atlas animations here, and that's a third global sort of thingy inside atlas.odin. And I said atlas.odin is pre-generated by the Atlas builder, but it's compiled as part of the game DLL. So in the game DLL, you can, from code, reason about, for example, if we go to play.odin, we have create. here I can say animation create.player, and this is just an enum. That's the animation. Which animation is it that I want to use? So what this means is that since these player animations live in here, I can from code at compile time sort of make sure that I use textures that actually exist. It's not doesn't have to wait until the program starts to know that the texture exists. The texture exists if it's in this enum, because this file is generated. If we look in the hot reload file here, it builds the Atlas builder and then it runs the Atlas builder, and down here it builds the game. So this always makes a fresh atlas.odin and make sure the PNG is fresh. So all that is always there. And these Atlas animations then, what is an Atlas animation? Well, that's just a thing. We don't need to look at everything here, but the important thing is that it says which is the first frame and which is the last frame. And since these are sorted by name, if we look in animation name, in Atlas textures, I mean. If we look in here, this animation this is the first frame of it and this is the last frame. It will just go between these two. If we look at some more complicated animation like the player head detached, then the first frame is head 0, this one, and the last frame is head 13. So that means that it will go between this frame and this frame. But since these are sorted in name order, what the animation updating code can do, it can just whenever if it is on the first frame, then it knows how long that frame is, and when that much time has elapsed, it just does +1 on the enum. It will get to this one, and eventually that number that enum is the number that enum represents will get to head 13, which is like I said here, the last frame. So when it will notice that, oh, we got to the last one. Now we're done with the animation. So that's where I have textures, tiles, and animation sort of pre-set up in a pre-compiled way so that I can reason about sort of statically in the code. So let's go and just have a check out how the Atlas builder works. It uses the asprite library for loading asprite files that's made by blob some number. I will link actually it. It's very nicely made. I will link it in the chat and later in the video description. This is the asprite Odin asprite library. So it's just for loading asprite. I think I can even write asprite files unless I'm wrong, which I have never done, but yeah. But that person made all that. So my Atlas builder, as you saw in build hot reload, it first builds the Atlas builder and then runs it. And this is a totally separate program that does two things. It outputs atlas.png, the Atlas itself, and it outputs this metadata file atlas.odin that I can use as part of the game DLL. I'm trying to, yeah, there we go. And so this is a separate little program. So instead of doing like complicated meta programming where some languages you can do like meta programming where you do a lot of things at compile time, or you try to solve this stuff within the language to be able to sort of do something like this. Like there are some languages that have like arbitrary compile time code execution, like for example Jai, John Blow's new language has that. Odin does not have anything like that, and that's sort of like a simplicity thing, that it makes the language a bit harder to understand and makes it harder to read other people's code. So, but what I do is just write a small program that outputs code for me. So this thing here outputs and we will not look at this you can look at this also part of the template. The template doesn't currently have any there's just a comment at the top of how to use it, sort of, and also in the README. But I don't currently have an example that uses this, but maybe I should add that. So if you go to main in here, this is not the most well-written code ever. I kind of use Odin as a scripting language in this program because I never free memory, since I know we just run once and then quit, because then the memory is freed anyways. So this is just, yeah, I just that's a thing you can do, right? If you just want to write a utility program and use that program as like, and use Odin sort of as a scripting language, you can actually just do whatever you want, and then you're done. And then when the program shuts down, which it always does because you just run once before every compilation, then all the memory it has allocated is freed anyways. Sure, the in-flight memory usage might be slightly higher due to maybe some initial parts of the program allocating some stuff that is not released, but maybe it will be like, I don't know, maybe the program will use 200 megabytes of memory instead of 100 megabytes of memory, but it's a development tool. Yeah, I wouldn't do this in a customer-facing tool, you know, but small shortcuts you can take. So anyways, what this thing does essentially is it goes through all, it looks in the textures folder here, and it finds all it looks in there, the textures there. Here is a constant that is set to textures. You can customize these things at the top if you want to use this. You can say, how wide is my tile sets? What's the tile size? If you use the tile set, otherwise you can ignore these two. And tile sets are files in the texture folder that start with tileset underscore, like this one. That's how it knows it's a tileset. And then you say which texture folder should it use. And what it does here is just that it just goes through all the files in the textures folder and checks, are they ASprite files or are they PNGs? And if they are ASprite or PNG, then it will, if it's a tileset, it will load tileset. If it's an ASprite file, it will load the ASprite file. And if it's a PNG, it will load this one. We can look quickly at the ASprite one. That one will just go through all the frames in it, and it will do some math to make sure that everything ends up, because there might be several layers in the file, so it tries to make sure that everything ends up at the right position. And if there are animations in the file, then it, which is if there was more than one frame, because you know this thing here for f in doc.frames, if this loop runs more than once, which will make frame index in my case be more than 0. Then, or more than 1, then I know it's animated. That's how I know it's animated. And if it's animated, then it writes out this animation thing, which it adds, which contains the first texture and the last texture. And the first texture is base name plus 0. And base name is, for example, this one here is called player. That's the base name. 0 is the first frame, and then it's how many ever frames it was. However many frames it was is covered by the frame index counter here. So that's why you get, for example, player 0 for the first frame and player 1 for the last frame, and player and head detach, player detach head. That this is the, let me show you here. The ones we saw here, player detach head 0. This is the first frame and this is the last frame, and that's just it has just taken the file name here and sort of transformed it using some, I think, base name. If we look up here, is it runs asset name, and asset name uses two ADA case, and ADA case is the case with the capital letter and underscores like we have in the file. So that's how it that just adds it to a list called animations. So in main, like I said, we have a list of animations and a list of textures. And all the frames in the animation gets added as textures, as well as all separate textures, and then you get animations if the if the ASprite file had more than one frame. And then finally, it's also the tileset stuff. Currently, I only support one tileset. If I ever need more than one, I will add support for that. That's why there is sort of inside here, it says T0. That's just me thinking ahead a bit. If I ever need T1 here, I can add it later. And then that can be rerouted to another tileset entirely, so that anything with T1 is supposed to go and look. It just goes to another rectangle inside the main atlas. So you can have two tilesets combined into one atlas, essentially. And like I said, the tile set looks like this, except that this, I draw the tile set like this. I've actually used indexed color here, and that means that I've set the green as the alpha color so that it looks like, you can go in Sprite into preferences and say that the background should be green. So in that case, this is the alpha color, and it's just, and this is the foreground color. And that means in the loader later, I can just ignore all the things that have used alpha color, which that's just so it looks correct while I'm working in here. It looks nice. I do the same trick in here, you see. So I just put this as the alpha color and I work with that. But then I make sure in Sprite to not write this green stuff into the image, and that way I can get this. Atlas where, this I had added just for clarity, but in the atlas is actually just transparent pixels, and I can just draw the game with a cleared green background and put the stuff on top with alpha enabled like this, just a single color. But anyway, so I only support one tileset. The load tileset proc here just, it does some similar stuff. There might be some stuff I need to improve in here, but it essentially just this one doesn't do the stuff. This one doesn't split it up into separate tiles, because as you see, this atlas here is sort of smartly packed. You have these here, and then these are the different tiles here. Because if you look at the tile set, these are the different tiles like that, and the tiles have all ended up sort of packed in here like that, and they can end up in any order. It doesn't matter. The reason to have it like this is just so it's easy for me to edit, but then in the atlas they can be any old way they want. But this code here just sort of fetches that stuff. In both this code and the other code, I check if it's indexed, which means that, like I said, I use indexed colors in all these. This one. And in that case, each pixel is actually a number. Is it 0, which is the first color? Is it 1, which is the second color? Is it 2, which would be an imaginary third color? Or 0 is actually supposed to be alpha. So it's 0 is alpha, 1 is the first color, and then any other colors. Yeah, that's a palette. And the palette is defined separately. So what I do here is, if it says that it's indexed, then I scan through all the frames and find a chunk that has a palette on it. And that palette is with mapping between these numbers, that 1 means a certain color. And in that case, this code here uses the palette to fetch it fetches from the palette the actual color on each pixel like this, right? It just goes through the image of each little texture and fetches those. So that's what that does. And I know that I actually don't even, ideally what I would do here is have a shader that sets, or maybe a shader or something, or maybe it's just part of this, atlas builder or something, that, because since I have a 2-color game, I could actually I should probably do it in a shader, but what I could do is I could modify the palette as the game runs, which just means that modify which color is this, the foreground, and which is the background color. And then I can, for example, have a setting for the player, like, oh, do you want to tweak your palette? Just like, in Return of the Obra Dinn, you can set the color of the two colors that exist in the game. So actually that I even care about the palette here is, it doesn't really matter. I could fix it differently, but that's just how I did it for now. And also because I try to make this so other people can use it. So if you have you use a nice palette, then you can do this to have your colors come out correctly. However, this one doesn't do any of the, this one doesn't care about the tiles yet, right? So you have load tileset here, and it's first, and now we get to the sort of the rect packing. So this tileset is essentially, you take a lot of textures and you say how big is each texture, and then you tell a rect packing algorithm to you ask it, can you please take all these rectangles that are the different texture sizes and put them in an optimal way inside a texture. It might not look like much yet, this atlas, because it... Now I enable the background just to see again. It might not look like much because this is probably the optimal packing of it, because this one is so tall. But if we started adding more, these dead spaces would probably get filled up pretty nicely. For example, if I added in a font and stuff here. But what this thing does is essentially... we can look at the tile set, for example. For the tile set, if we have a tile set, it says if the tile set pixels, this tile set will contain the data it extracted from the asprite file for the tile set, right? And what it does, it just goes through with these two loops, the different tiles, and it checks that unless all the pixels are blank in it, which means that it can skip that tile because it's just blank. Unless what does this thing do? Yeah, so this thing just I'm trying to think of what this thing does. Oh yeah, okay, so this thing is just for checking for the blank pixel. It doesn't really matter. But what it does, anyways, what it does here is that it has this list of pack rects, and that's just a list of rectangles. And it says the ID of each is some ID that I made up, which is one ID for each tile ID, and this is just like a magic ID I create by putting together the X and the Y of the tile set. And that's just to be able to identify which tile it was later. But the important thing is that I take the width plus 2 because I want some padding around each tile. We'll see why later. But the pack rects are then just, this is just one rectangle for each tile in the tile set. And that's the width and the height of this rectangle. And, you know, for a tile set, this is almost trivial, really, because the only thing you need is how many tiles are there in the tile set, and all of them are the same size. So this stuff is actually the same. The only thing you need to keep track of is which tile is it that this actually represents, so you can put them at different places, and you know yourself which tile it is, so that you can later write this atlas.odin stuff and match it up down here with the correct tiles and stuff, right? But so it just forces on all those pack rects, and it does the same for the textures here. The textures, each texture might be a different size. That's can be the head texture here and the body texture, and then it also does fonts. I currently hard load a font TTF here, try to load it, but it loads that one and then gets all the letters from it and makes one rectangle for each letter that I want. And I have a specific series of letters I want. In this case, it's like a hard-coded thingy here, I think, somewhere. Letters in font. This is not a good way to do it. This part should probably be replaced because it's bad for localization. Maybe I shouldn't even use the atlas for fonts, because if you want to support Chinese, you suddenly need a lot of letters. Maybe you can put them in an atlas, but it might get a bit messy. People I know have used something called Font Stash, I think, for this instead, which might work nice. I don't know. But yeah. So then you have all your textures, all your tile set tiles and stuff in this pack rects array here. And the pack rects array is just a dynamic array of rectangles, and the rectangles, these rectangles are defined by the rect pack library, which is actually imported up here, And that's actually the STB made by Sean Barrett that comes as part of the vendor library. So rectpack is, well, that's the header. Oh yeah, I don't have it in my project, so I can see it. Anyways, it's there. What rectpack does is that you just have a list of rectangles, which is an X position, Y position, width, and a height. You just set all the width and heights of them. They don't have a X and Y position yet, because that's the thing that the rectpacker figures out for you, where to put them. So you just initialize the rectpacker a bit like this. There's examples on how to do this with the STB rectpacker stuff. And then you add stuff to it. And then down here we say please rectpacker pack the rects. And here they are, the rects, and it returns 1 if it succeeded. And if it succeeded, then now all those rectangles inside there will have a position that I can use. So then I can just go over the pack rects, and I can take my texture. I check each one, and here I can get I encoded that little rect ID in the type. That's the thing I did for, like, this is just, you can figure this out. This you can do in any way you want, but you can essentially maybe have, like, you can bit shift around some numbers into an integer to be like, there's a 1 here, that means it's a tile, and here's the first X position, here's the Y position, and then you do a couple of different ones, because the rectpacker has, each rectangle is X, Y, width and height plus an ID, which is a number. So you need some way to sort of put that your stuff in there. But you can do that any way you want. It's just a number that identifies which specific thing is this. So in this case, I can fetch the type from the ID. Type here, so it's the shapes texture. That's just a thing for Raylib. That's you saw that in here. There's a white thing here that's just used for drawing like rectangles and circles and stuff. And you can put that in your own texture like this, just to make it. If you have any post-processing stuff you want to do, even on those, then you can get that. But that's not so important. So anyways, if it was a texture, for example, then this stuff is run. And what this does is that it has the atlas here. This is the final picture that is going to get written to the hard drive. And it says generate an image. I use Raylib here. You could have used like STB image, I think it's called, or something. But I used Raylib because I'm used to it. I say that atlas is 512 by 512. That's atlas size. And it's blank, all blank colors. So I generate that. So then I just go through all my packed rects, and I know which type it is, and then I can get the index using the ID also, so I know which index in the textures array it is. So then I know that, and then for each of those images, it has extracted the ASprite data for each pixel, right? And when it has that, it can just take the pixels out of there and say they are this big. And here's the source rectangle to read from inside that image. And the dest rectangle is the size of the texture. But more importantly, the rp.y and x here is where did the rectpacker decide to put these in order to make it efficient. That's what and that's the destination rectangle. It writes into with which it writes into the atlas. So where in the atlas should it write? That's the destination rectangle. So it draws that. And Raylib has this sort of stuff to draw. You can draw textures, which draws on the screen, on the GPU. But image draw is for drawing things into images. So it's sort of like just to work with images that are not on the GPU. It's more for doing data processing in a sense. And then when it's done with that, it just takes Atlas Texture Rect, it makes one of these. It says, this is where it is in the final thing, and this is the name of it, and how long the frame is, if it had a length in an animation, for example, and then it adds that Atlas Textures. Glyphs are the texture, the font letters. It does a similar thing, blitz them into the image. and then says which glyph is it, where is it. Tiles, it fetches the X and the Y from the tile ID, says also what does it say, tile set here? Oh no, it says tile set. I was thinking of the font. So in this case, yeah, it fetches the X and the Y for the current tile, and then it just sets up an image that is the tile set, and it copies from the tile set, which is this stuff, where in this tile set are we copying from, and then it writes it to the atlas. You might see there's some padding lines here below, because actually, if we look at these, if we look at atlas dot, this one, it might be hard to see, but for example, this one here, this is a tile, this is the jaggedy thing that's here. It looks like this, but when it's in the atlas, this is going to be a bit hard to see, but you see that below here it has actually added two, or maybe it's this one. It doesn't matter which one it is, but you see that it has added extra stuff below here. That's just because I use non-pixel perfect rendering, and when the camera zooms around and pans around, you might see funny lines in between things when you get like these. You essentially see. It looks like you see a little like lines in between the tiles. It just looks very bad. Many different ways people have thought about trying to fix that. I think the easiest way is just to you put your tile here. Is that no? You put your tile. Is this? Oh yeah, I forgot it's. So you put your tile like this maybe, or I think this is one of the tiles. It looks like this. Yeah, this 8x8. So you put it there, and then you just draw the padding around it. So when it samples this area here, if it accidentally spills a bit outside when it's sort of panning the camera around, because that's what can happen, because the UVs it uses to sample textures, those are just floating point number. It's not very precise. It can just be a bit wrong sometimes. So then if it accidentally hops a bit outside, then it samples the same thing again. So you don't get any of those problems. Yeah. So that's that. That's why doing this. So these padding lines down here. This is the top line, so it just copies the top of the tile up a bit on the bottom. So it just adds these. It just adds these extra things all around. And finally, we are done with what the Atlas Builder does, except for writing out all the stuff. So then it crops the image. You don't need to write all, like it's 512 by 512. I just crop out the stuff that's not important. That procedure does this. Then I export the image to atlas.png. We looked at that one a lot already here. This one is exported by that line. And then we need to write the metadata. Remember, this file here is generated by code. I think in Odin maybe you could set up like the Odin like the core library comes with the core collection comes with some stuff to reason about Odin code. Perhaps you could like set up and export Odin code in there. I'm not sure. I have never tried that. I've just done it the super unsmart way and just open the file atlas.odin and I just written. You see, you might recognize here are the tiles, atlas tiles, animation name. I just write all that stuff out manually, and it wasn't hard to write. It's very straightforward to write all this. So it just here is the textures as a rect, offset, blah blah blah, and then it just goes through all the atlas textures and write those out. Does the same for the glyphs. Does the same for the here. It writes all the tile IDs, and like I said, these are sort of pre-generated to always be 10 by 10 in my case, because my tile width is 10. And then it makes an array of atlas tiles here, and it writes it out. So this is just writing raw text, like just writing text to a file. That is code. And you will immediately know if you did an error because it won't compile, because it compiles as part of your game DLL later. So then you have all your stuff in here. This is all generated by that code. And then, for example, you have here, that's how you end up with Atlas texture being an enumerated array. This is a type of array that where each of these enum values must be represented. So it maps from an enum name to Atlas texture. And in all these cases, it just, then you know this is the rectangle, this is the offset you should add when you render it, because we have moved it a bit, we removed dead pixels essentially, or A-Sprite didn't have all the pixels in the layer, so sometimes it's, this is the stuff I showed before, with like you have an offset of 12 from the top here, because for example in an animation like this you have a lot of dead pixels up here, and these are not included because it's tightly packed here, so it needs to know how much to add from the top here, because all these have their head at the top. So the rectangle just points out this stuff essentially. And then it says an offset also of how much it's offset from how it originally was positioned within the animation. That's that. That's the Atlas builder, run as a separate program, like I said, at startup. And then this program will output that atlas.odin file, which will get picked up down here when it builds the game DLL. Hello, Obs. Obs is asking, is this your new main project or are you just working on a prototype? I guess it's both, but thank you. It's both, I think, because I'm not 100% sure about it yet, but I'm having more fun with this than any of the other prototypes that I worked on. But it's not much yet, but I can just, you have a feeling that it's a bit fun to work on, and I can see how I could make fun sort of Metroidvania things where maybe I give you these. I'm going to try to figure out more funny skills, because I have one that's this nose that I can grab the wall with. Maybe it should push buttons instead, who knows. Then you have the head that pops off that can roll around and then reattach. And then that one can go through narrow spaces like this, I think Metroidvanias are a lot about figuring out these different skills and how they can be some synergy, or how they can be used in different fun situations, and then build a little world around that. So it's fun to have this. I'm gonna build out this playground more and more here, and just see where it goes. Okay, that's the Atlas builder. So we were looking at, in the game, we were looking at the draw proc. The reason we started talking about Atlas builder was because here I used the Atlas rect, comes from there. This is the tile. This tile index is one of these. That comes from the editor. The editor has written that into the list of tiles, that index. You can flip the tiles, because you see this tile here is the same as this tile here. So I have a flip flag, which just flips the width of the rect it samples using, and that flips, that tells Raylib to flip it. And then it draws it. So all these are drawn using the same texture. And the nice thing about that, the reason you want to do this from the start, which maybe I should have mentioned, is that when you use the same texture, then in case of Raylib, in 2D stuff like this, as long as you use the same, if you use the same texture with the same camera and the same shader, essentially, then it can batch those things together, so it can render it using one draw call. It just tells the GPU once, hey, draw all these things at these different places with this texture, which is the Atlas and stuff. So we can, all this here is, all this on the screen is currently drawn using a single draw call, because all of it uses the Atlas. Right, so that's the drawing the tiles, and like I said, this is not optimized at all. I will add later some kind of spatial partitioning, because I don't want any loading screens. I just want you to walk around in the world and I will split it up into some kind of, I don't know if it's 10 by 10 tiles, 20 by 20 tiles, some kind of chunks, and the ones that are nearby the camera will be processed here. Just it's like a simple frustum or camera culling thing, really. But that I can do later. It's not important right now. That's the kind of thing you could worry about early, but I know it's a solvable problem, so I don't need to worry about it right now. It's more fun to do something creative and see if, like, it's better to just do something on the game and see if it's fun to work on the game than worry about technical things that you know you can solve. Then draw goes over all my entities and it draws them using this proc here, entity draw. Entity draw is just similar to the tileset stuff. It has, each entity has a position and it draws using the atlas at that position. There's some more slight things with where the origin is, because if we press F3 here, then we see it's hard to see maybe, but the origin of the player is this yellow circle that is impossible to see down here. It's here. That's the origin of the player, so it just offsets thing a bit. Yeah. David Dash asks, how could you implement spatial partitioning in Odin? So for example, for the tiles, I would like some kind of spatial partitioning. What a partition then is for the tile, like, you can have both tiles and entities, right? And each, I would never, like in a game like this, I would never do, you know, some kind of quad tree or whatever it's called, like where you can have like super efficient, because you don't need it. You just need maybe you can split the game up into chunks of 10 by 10 or 20 by 20 tiles, sort of. But then each chunk would just be something like like 10 by I don't know, maybe something like this. This is a chunk, these are the tiles, and maybe the chunk has a position which is vector 2 integer, like where in the world is this chunk. I'm not sure if this should be here or if it's known outside depending on the index of the chunk. And then you have your world is like, this is a tile chunk maybe, I don't know, I haven't figured out this stuff yet, but maybe chunks is some array of I don't know if it's a dynamic array of tile chunks, and then you have maybe you can have some lookup. Maybe you could have some lookup down here that's like, yeah, you because the thing that needs to be fast here, right, is to go from a world position, say here's a world position, which sort of chunk, if you think that the world is split up into rectangles, which chunk is this world position inside? So that's sort of, I would think that's the tricky thing, I guess. And then, but then you would either, you can have these chunks made in such a way that it's like 100 by 100 or something. I don't know, or maybe this is allocated dynamically like this, but you make sure that the top left chunk is at index 0, 0, and then they're organized like in a grid, so that you can use you can take a world position and figure out the index using, like, oh, you can see this is supposed to be at x20, y30, and then you can divide that by the tile size and then get to a tile xy maybe or something, and then you can work backwards from there and figure out an index, where is the chunk, because you would figure out how big is each chunk, and then sort of take that index backwards. And then when you're inside a chunk, you just need to fetch all the things in there. And you could do something similar, I think, for entities, but it's just something simple like this, really. Is all you need. You don't need to have like super fancy algorithms that do cool trees. Like just do something like this. This will work for many types of 2D games that are not too advanced, just to have some kind of thing like that. But yeah, like I said, entity draw is just like draw a texture with, like, it's just the same as the tiles, but it's just it's not aligned to the grid, because you can walk around a bit like however you want, right? I have my entities. We can let's take a step back, and we have looked at the draw procedure now a bit, because it's just currently just tiles and entities, and we saw how we draw a general entity, and then we can draw a player. It just switches on the type of the entity here, and if this is the default case, if I have some special kind of drawing I want to do for that type of entity, then I call a different procedure here. So here I just call player draw, which does a bit different things depending on, like, for example, this thing here is tongue. It should be nose, but I thought it was tongue. It's tongue extending, retracting and stuff. So these things are drawn because it needs to draw this line here. So that's drawn like that. But let's take a step back and look at what the update procedure of the game does, right? So we have something like game update here. We go back. And like I said, we use this kind of fixed time step stuff here. So here is the tick procedure. And for each, this one runs dt, like I said, is 1/60. That's like 16 ms roughly, 16 milliseconds. And so then you tick, then it's just this procedure. And I just use I could have fed, you know, dt f32 here, use that, but I just have a global variable called dt that is 1/60. It's just a global constant. This gmem.timer is just for keeping track of how much time has passed in game. Just ever counting up. And the only thing it does currently, since I haven't done much in the game yet, there's no like enemies walking around. It doesn't need to loop over all the entities yet and figure that stuff out. And in that case, if you were to loop over all the entities, of course, maybe you would need something similar again, where you only update the things that are kind of close to the camera. Maybe the camera plus a few camera widths in each direction, so you don't update every entity in the whole world. But you can try doing that first and see if it's fast enough. But if it gets a bit slow, then you could use some spatial partitioning to sort of figure out which set of entities to actually draw. But I don't do any of that right now because I only have the player. So I have this controlled entity thing here. That's the player, because I have the controlled entity, because now it's that thing, and we do this, and now it's this thing, and that's a separate entity that I'm controlling. So then I switch this one out. So in here it just looks at the control entity and does some different things. If it's the player head, it runs this procedure. If the player is normal player, it runs this procedure, and then it updates the camera position based on, like, the camera position Y target is, for example, this thing here. You see it sort of moves the camera up a bit and stuff. That's just based on if you're far up on the screen enough, it sort of changes that. But that's gonna be reworked. That's just my first little implementation of that. And this is the thing that then, based on the target, it sort of lerps. It doesn't lerp, this should really be a lerp, but I was a bit lazy when I wrote it. But it moves the camera based on the difference between the current camera Y position and the camera Y position target. So that's why it can do these kind of smooth things here, because it just updates the camera position Y like this. Not very important. So what are these entities then really? So we can go to entity.odin, which I have here. So an entity is it is a struct that the handle I can talk about later. That's related to the handle-based array, but it has the entity type, which is none, player, body, head. None is the default. Like, you can use none if you just want something generic. Like, if you just want something that just draws using animation or texture, and then you use that. But then you can use these to specialize things. It has a position, a velocity, a rotation, an origin, an animation, or a texture. It uses animation if it's set, otherwise it uses a texture. And here you see texture name. This is just an enum, right? Animation is a bit more involved. It says which animation in the atlas is it, which is it this one or none? And then it's which is the current frame, which is just which of the because for example in this case the first frame is player detach head 0 and the last frame is player detach head 13, so it just knows which one of these are we currently on, and it will step through them, right? So that's what the animation is. It's just which animation and which is the frame, and then it's a timer for knowing when to switch to the next frame and stuff. And then it's a facing west or east. That's because you can do this, right? That's the thing that sort of flips the texture when it's drawing it. Last grounded, out grounded, time, collider. These things maybe could be moved to the player, but they're currently there. And then there's the collider rectangle, which is, if I enable my debug rendering here, it's this one. If we're the head, we see that it's a bit smaller and stuff. And what I do so these anything that's sort of generic that I think many different entities will want, I put here. If it's something that I only think that only one type of thing wants, then I have the entity type data, which is a union here. And this is just like a variant, so you have player data here. Player data is defined in player.odin. It has the current state and how long it's been in that state, and the states are like default. The head is detaching, which is when it's playing this animation. It has different states for these nose or tongue, whatever you want to call it, extension things. So those are states in there. And those are stored in there. So it's sort of like, if it's anything that's totally ungeneric, then they might go in here. But I will try to go a bit with sort of like doing an entity mega struct, where if it's something that I think could be fun to have, like, I won't be super scared of putting things directly in entity, even if it grows a bit, because there might not be that many that it matters. And the fun thing that happens, if you don't hide your data away inside like some union so that it's hard to get to, if it's just like something that, like if you're an entity that has some field on it, and you want to affect some other entity, maybe it has like dizziness, I'm just making shit up here, but maybe there's an F32 called dizziness. If that's on the player only, then you will have to get through the data here and blah blah blah. But if you put dizziness on all of them, then you could maybe get some emergent gameplay where you actually look at that variable for any entity, and maybe one entity can both put it on the player but also on other entities. So the code is easy to sort of, because it doesn't need to specifically go in and poke at the player, or specifically go in and poke at the angry flower NPC, or something like that. It can poke at a general one. People think, I think in general people think that it's always good to organize these things as efficiently as possible with the like having a union, for example, or in C++ maybe would have some kind of subclass and sort of tuck everything away very neatly. But there is something you lose there, in the sense that your code becomes more and more specialized. And if you want to have emergent, funny gameplay, then it can actually change how, because it changes how you can program. And if it changes how you can program, then the game will work differently. So if you have many generic things on your entity that the different entities can poke at each other, then you can get these funny things that happen. So it will actually change how your game feels, I think, because it's too much work sometimes to add all the special cases for all the different entity variants. If everything is tucked away in like player data, angry flower data, I don't know, bucket data, you know, if you have like lots of entity, specific entity types here. So you should think about it when you add stuff, like how do you want your entities to interact in the game? Anyway, so that's the entity struct. So that's what I'm going for. Not be afraid of putting things in here, but if they are only for a specific thing, like player states about head detaching, which is this super specific player things, then they go into here, into the data here. Player data is a union. So for different, depending on the type here, entity type, for the player, I will make sure to set this one to player data. That's sort of, if we look at in player.odin, there's a create proc. This one makes an entity that has a position, it's of type player, it creates it with the player animation, which is this one, and then it sets the origin to the middle bottom, which is down here, and then it sets the data to be the player data. So we just make sure that everything is nicely set up. Right. The entities themselves live in a handle-based array, which is this thing here. We can see that one in game. If we go to game.odin, what have we done in here? Oh. I'm just gonna undo until, oh wait, we just remove this and it's fine. In game memory we have a list. This will eventually go into like a world struct. That's maybe I can load from the level data. It's not so nicely set up yet. But you have the entities handle array here, for example, here. And this one contains all the entities of the game. And what it does is essentially, it's just an array. This is like a polymorphism, essentially. Like it's well, it's a generic struct, so you can say it's parametric polymorphism on a struct or whatever you want to call it. It says that T is used here, so since I wrote entity, this array will be of a dynamic array of entities. So these handles are just an index. Where in the items array is it? Plus a generation, which is ticked up each time a slot is reused. You can find this. I think I removed this one from the. I'm gonna add it back actually to the template, I think, because I think it's generally useful. But anyways, what it does, it just, instead of whenever we saw this here, for example, the controlled entities and entity handle. So instead of storing a pointer to something, you store a handle. The handle is an index plus a generation. That means if this entity array is ever reallocated, you just have an index. It's fine, because that's you just ask the handle array, like you just say, oh, get the thing at the array with this index, and then it returns. In this case, here you can add a pointer to something inside the handle array using an index. So that's what that is, and that prevents, you know, if you store pointers here instead, then this pointer could suddenly point to memory that's no longer existing, or like it's no longer the one used by the entity array if it's reallocated. I don't really reallocate it. So that's fine. But the other thing you get is, if this entity has actually been destroyed, in that case, when an entity is destroyed, then it is removed from the handle array using this procedure, and then the generation on that slot is +1. And it always checks, like whenever you use, for example here, get pointer, it checks, is the handle exactly the same, the one you're passing me and the one on the slot. So if the generation is different, then it won't say it, like, no, you don't, then you get nil here. You don't, like, the index and the generation must still be the same on your handle as the handle that sits on that slot. Otherwise you don't have the same anymore. And that's just to prevent, like, if you're holding a reference to an entity, then if you're holding a reference to an entity and it is removed and then something else is placed at the same spot. Even if you use an index or a pointer, doesn't matter. But in both those cases, the new thing at that position will still look like, oh, but it's still an entity there. Everything is fine. Let's just continue using it. But you're actually using a completely different entity. So by using the generation there, you make sure that it's actually the one you originally assumed it was. Davidash asks if there's any problem if the generation overflows. You see, this is a U32. U32 has, what is it, 4.2, well, how much is it? 4.2 million, 4.2, I don't remember anymore. A lot. I would say that you have to be, it's a risk you have to take, but the risk is essentially that you, for example, have generation 5 on your slot, and then your game has been running for forever, and you're like, okay, everything, you have this handle lying around, and then it has wrapped all the way around and come back to 5 again, gone up to the maximum value of a U32, and then back again, which is an enormous amount of adding and removing, of like removing and adding or reusing the same slot. And then it has to, exactly when that happens, you still have to have a reference lying around to that one that has the generation 5. That is so unlikely that you don't need to care about it, I would say. It's also what you can do is, like, your gameplay code probably checks every now and then, like, oh, if you have a reference to an entity in your gameplay code and you try to fetch it and then it says no, there's nothing there, then you could clear that handle out or something. Yeah, you can do stuff like that also. So it's very unlikely, and you could also clear your entity handles if you for example use this one to get a pointer using a handle array, get a pointer and you get nil, then you could, whatever entity handle you had stored, for example this one, I could clear it to just empty. Another thing I do here is an empty handle is always okay to have, because that refers to index 0 generation 0. That's a zeroed out handle, and I make sure that there's always something at that index. So there's just a totally empty entity at that index. So if you get an entity and you get back the sort of dummy one, which, for example, here you have get, this one says returns an entity plus a bool. So if you don't check this bool and you just use it anyway, or then you might get a sort of dummy one. It actually doesn't even return a dummy here, but this just makes sure that at the index 0 is never used. It just puts a dummy thing there at index 0. And you will always get something for index 0. In the pointer case, you will get nil, because I don't want you to go in and accidentally edit that thing at index 0. And in the non-pointer case, which is this one, where you just return a value, you get this dummy thing that doesn't point to that is just returns an empty entity here. And that way, if you use everything inside, I try to make it so that everything inside here is okay to use with the 0 value. If you try to render a texture or animation with this all 0, they will just use this rectangle that is all 0. You just not render anything. For example, the collider with finite 0 is fine. So everything in here is okay to have zeroed out. So you can just return a zeroed entity. It's totally fine. And that's whole mindset that the 0 value is useful is called 0 is initialized. And it's Odin, both the core library, the core collection, and how the language is built, tries to make it so that the zero value is as useful as possible, because you can very often just make sure that your code works well with the zero value, and then you get less issues, and you can, in many cases, also just initialize a whole struct to just leave it uninitialized, because in Odin everything is zero initialized by default, so you just leave it and then it sort of works fine. And also this trick with like if in some cases you can add at index 0 a dummy, so that if you then index equals 0 means nothing, but if you accidentally also use that index, then nothing happens, because you just get back a zeroed out thing. And also, like, nothing, since that index is already used up at index 0, then you can't accidentally, you won't append anything to the handle array that actually ends up at index 0, but then it can't be used because it is a 0, which we say is the nothing is there index. So that's why handle none here is just a handle that's all empty. Index 0, generation 0. That's what I use to say nothing. So index the first item in the handle array can never be used. So that's how the entities works, and that's how you can get an array of things with stable handles and all that. And you can store the, like, you can using HA get pointer, you can fetch this pointer here. No, the pointer you get there, you never store that. You just use it while you're doing your computations and your gameplay code. You never store it. That's the whole point. You don't store pointers. You store the handles. Yeah. Yeah, so Davidash says, I make a simple system to check and always changing the handle is fine. Yeah, I mean, yeah, you don't need to do much at all, really. It's just like in some cases when I would say you don't even need to care about it, because it's so unlikely that you have something still in a slot with the same generation when it has wrapped around. I wouldn't even worry about it. But you could of course, if it returns nil or it says there's nothing on this slot when you try to fetch something, you could clear it if you want to. But I wouldn't even worry about that. It also depends on which kind of game you're making, right? If it's a game where... No, I just wouldn't worry about it. Anyways. That's the... no, not the editor. That's the tick. So the tick then just fetches the controlled entity, like I said, and this uses HA get pointer here, you see? Fetches using the control entity, and if it's not nil, I switch which type it is, and I do the tick for different things. And down here, like I said, I set up the camera. The head tick we can look at first. Is very uncomplicated. That's this one where you roll around. It just checks the input and changes your facing if you're moving left or right. Then it's presetting your velocity based on your movement, and then it rotates also based on your velocity. That's why it rotates like this. And then this code here is for recombining. This is just a thing I hacked in. I will do this nicer with a proper animation, but this is just for, it tries to find the entity of type player body. This thing currently just searches through all the entities like this. If the type is the one you wanted, player body, then you return that one. Again, with some kind of spatial partitioning, this could be very more efficient, but I'll get to that another time. Yeah, so that's what this thing does. It just checks if this green collider here, it checks if this the head is inside that one, then it just it just removes, and here we see HA remove, which is removing from the handler array. It just removes the body and the head. P here is the entity that's sent into head tick. It removes it all, and then it makes a new entity, which is the player again, the normal player, this one, at the position of the body, sort of. Yeah. And you can jump while you're the head. I don't think that's just something that's left over from the player. It's just a bit weird. You can jump. I don't know. I might remove that. This is all experimental. For the player, you have player tick, and there in here this is more complicated because it has all the different ones. You know, it has this one where the head pops off, and it's a lot of different things. But this essentially uses here I use the data, the player data on that union I showed before. So it fetches the player data, and it assumes here that it is of the correct one, because when I run player create, I set the type and I set the data. This would probably crash right now if it would if player data wasn't on the correct type here, but yeah. So here it just goes through the different states. If you're in the default state, then you can walk around. It updates the animation here, which is this animation, and this animation update uses this animation struct, just like which animation, what's the current frame, what's the timer, and it just like if it just decreases the timer by the DT, and then if the timer is less than 0, that means it's time to change frame. Then it just adds 1 to the frame, and then it checks, is this frame bigger than the last frame of the animation, which means is the current frame bigger than, for example, in the player in the case of the player walk cycle, is the current frame bigger than this enum value. Then it loops around and gets here again. So it just hops between those two frames essentially. But it just uses that using enums. It can know how long an animation is in total by looping over all the animation frames from the first frame to the last frame and just adding up the duration on each. Right. And then, yeah, that's sort of it. And it also, of course, resets the timer to the duration here of the new frame here. That's the whole animation stuff, using this fancy Atlas up pre-generated stuff from Sprite files. Yeah. So we have, that's that, and then you can jump. It just sets the velocity upwards if you have been grounded. And I currently have some tick physics. This is all also, this needs proper implementation. This currently just moves you in the Y direction, checks against all the tiles, and moves you out of collision, goes in the X direction, goes over the tiles, and moves you out of collision in X direction. This creates quite stable, like when you do split it up into this, moving the position like this separately in Y and then in X, it creates quite stable, and then resolving the collision for each direction is like that. It creates quite stable collision direction, but it's as you see, I loop over all the tiles. If I had many entities that walk around, then this wouldn't work. But I will worry about that later. I can replace that later. Just what I have for now. And then if I press the separate button, which is the head detach with the hint, boop, then it changes the player state to the head detaching. And if I press the tongue, this tongue nose button, then it changes to this extending state, and the detaching state then is just another thing in this sort of little state machine here. This one just it does a tiny camera lerp because the new head will end up at the slide. You see the camera moves a bit there. That's just because you're new, but that's just why he just does this. It's a bit of a hack actually, the camera X offset, but never mind that. But then it updates animation, and animation update returns true if the animation has looped around, if it's finished sort of. So if it loops around at least once, then it knows it is, comes here, it's at the last frame, then it knows it's done. So then it creates the head, which is another entity that has the player head as texture, and it's of type player head, and then it adds that as a controlled entity, and then it also adds the body, which is just this thing that has texture player body and type player body, and adds that as an entity, and then it removes the player itself, which was the thing that was playing the animation that did this. I think it's easier in many cases to just add and remove entities and make sure to position them, like, because this is one big animation that runs here, and then I just make sure to position the new head entity at the exact same position as it got from the last frame. Yeah, and especially if you're working alone on a game like this, like if you have hot reload and you're working alone, then you're the one making animation, so you can, if you need some offsets at some point, like here I needed to have like it to be free higher because of how the animations line up, the head. I just added that there, and I just found this value by like if it's 10, you know, if I play this and I press A and it's 10 there, then it was too high, so it fell down. So I just tweaked this with hot reload until I found something that worked fine, like that. And you can just hard code that in really, because you're the one making the animation if you're a single person making a game, and you're the one making the code, so you just have a feeling for how it all, and you have hot reload, so you can just dynamically sort of just play around with it. You don't need to make it, you don't need to make a super fancy data format for everything that has everything figured out, because with hot reload data becomes code. No, code becomes data in a sense. And then, yeah, you know, we have other states like tongue extending. When the tongue nose thing is long enough, it gives up and starts retracting again. Or if you hit a wall, which is, it checks the collision here, then it does a retracting pull, which pulls you to the wall instead. And that's just these two. This retracts the nose, and this pulls you to the wall. And it just does different things. Like, in this case, it sort of sets the player's velocity and ticks the physics, and in this case, it just moves the tip of the thing back. So that's how I implemented some of the gameplay stuff. So that's that for the gameplay stuff, really. And we talked about the drawing already. I didn't mention the, like, so we have entity draw, which is the general one for general entities. It can have an animation or a texture, like I said. You know, here just like if the current frame is, if there's an animation, then it uses the texture for animation. If there's not an animation on the entity, then it uses the straight texture. But then you have stuff like player draw, which is a separate proc, because it needs to, in this case, it needs to add in this line here. So I switch on the type and just call a different one, and this one just draws the line, and then it draws, and then to draw. So it draws the line first. And the line is just a line from the head to wherever the sort of update code has decided that the tip of this nose here is. So that's mostly that for the gameplay code. We can... one cool thing I have that I want to show is if I press F1, then it says auto reload in the corner here. And what I can do then is I can go to Sprite, and I can go to, here's my tile set, and let's see, here's the ground thingy here that's used everywhere. We just delete a bit from there, save, and then it appeared here in the game. So I can just sit here and sort of like la 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 paint, maybe change that, and I can work a bit on this one, save, and you see it's all just sort of updating there. Also works, of course, since the animation go through the same thing. I can, in theory, like open the player. Which frame is it? It's on the it's on this frame right now, so I could make the head flat, save, and then it became flat. So how does this work? What's happening here? So when this sets auto reload here in the corner, it's because gmem.autoreload is true. Then it draws that thing. Okay, how does gmem.autoreload become true? Because you press F1, that flips this flag. Okay, but when that flag is flipped, the first thing it does in game update is that it goes through some mystical list called file versions, and then it checks last write file date, and then if I'll explain what these things are, but if one of the files I'm looking at has changed on disk, then I run build hot reload, and this, so the game tells the batch file that builds the game.dll, please run yourself, and then the other code that checks for the game.dll changes will see that it has changed if the compilation succeeded, and it will reload. And with the reload, it also, since build hot reload updates, that runs the Atlas builder, it will update both the PNG and the atlas.odin metadata file. If it was just about changing the texture, then I could just unload and reload the texture. I wouldn't need to run any compiler at all. I would just need to run the Atlas builder. But since I have this metadata about where things are in the Atlas, I run the Atlas builder and then recompile the whole game DLL so that the game DLL can use the new updated Atlas stuff. So that's what it does. It just checks if the modification date on one of these files that are in this mystical file versions array, if one of those is different from the one that it previously had, then it runs this. So what's this file versions? Well, file versions is this array here. And this generated, this is git ignored. So this has absolute paths that only make sense on my computer. Doesn't matter. So it says texture is player, you see this the player, body, detach, and then the tile set, and it has these timestamps on them, which is, and these times, file is auto-generated. It looks into the textures folder and writes down these names, and then writes down when they were modified. So that and then it puts this file and it's compiled as part of game.dll, and then it can, while the game is running, just fetch this file again, which is what it's doing here. It fetches the last write by name and checks if it changed. And if it changed, it tries to issue one of these reloads. So that's what that does. And this, the person who is a bit build hot reload, you might see that there is actually a file version builder. I have done one more meta programming, whatever you want to call it, like code generation is what we call it, code generation program. So it builds the file version builder and then runs it. The file version builder, of course, then just like the Atlas builder sits in a separate small directory because it's a separate package, separate program, the file version builder sits in here. This is much simpler than the Atlas builder. It will just make the file version.odin file. It just generates this file and with a struct and a list in it. So it's just like, okay, here's the struct, path, modification time. This is not, I had support for checking if Odin files changed, and if I just saved Odin files, then it recompiled. That all went a bit crazy every time I made an error because the game just started compiling over and over. It was just a bit, I don't know. I think it's better to do that manually by pressing F7 in here and do that for textures, because the thing with textures is that you're sitting in a sprite and drawing, and when you're doing that, you don't want to switch to anything else and hit the recompile, because it must be baked into the atlas, and everything must be fixed. So it's nice to have the auto compile, the auto reload and auto rebuild of the game, and building of the atlas and everything while you sit and draw. It's super good, because I think you will make better art because of it, because it will be easier to iterate on your stuff. But this thing essentially just writes this file versions.odin file with this struct here, like this, and then it goes through the textures folder, dir path to file info. This just fetches, all the files inside the textures folder and checks if they have the file name asprite, ace or png. Then it checks the last write name and it outputs their path and modification date. And then that can be compared then while the game is running, which is what is happening here. Eric Park says that they ran into the same compile loop stuff. Yeah, it's like when you do the hot reloading, and then when you do the auto reload with .odin files, when you look at the Odin files, yeah, it can get a bit too much. But that's fine, because you editing code, you can press the compile button in the editor. That's fine, but you can do that easily from within asprite. So then it's actually useful, I think. That's the auto reload. So that's my main tool. Like, and David Dash says, there's so many tools. Well, it's just it's the Atlas builder and the file version builder. Those are the ones that that's a lot of like content pipeline stuff. And then it is main hot reload for loading DLL, and then you build all the stuff in the root of the Metroidvania repo here as the game DLL, and that is the stuff that goes to the hot reload. So there's like 3 things essentially. There's the 4: a main exe, game DLL, Atlas builder, file version builder. Of course, when you ship the release version of the game, the hot reload stuff is only for developing. You don't want that in the release version, because it's just an extra thing that can go wrong. So the release version runs build release.bat, and this just run Odin build main release. It doesn't even build the hot reload program. It runs, there's a separate file in here, and this is a simple thingy. This one just inits the game window, inits the game, runs it. There's no hot reload code here at all, as you see, and then it just updates it every frame, and then it shuts down. And then there's some tracking allocator stuff here that is optional if you want to track memory leaks in your release build for some reason, but it's off by default. I also put my temp allocator free. The temp allocator in Odin is used for when you build temporary strings, construct temporary arrays that only needed during one. It's not needed in the long run, so to speak. You just need it for a frame or for one procedure call. Then you use the temp allocator for that. So I use free that. So anything that's allocated on temp allocator is valid until the end of the frame, both in the main release, but also the hot reload version of it also has free all context of temp allocator here. That's mostly it for the game. The only thing that I haven't talked about is the editor. I will just quickly say something here. The editor is, if you press F2, I showed this a bit before, you get into the editor here, and then you can edit it and turn it off and on, turn it off and on and on. Currently I don't have, well, let's ignore what I currently don't have, but what editor does, it just draws the same way, but using the editor camera, which is a separate camera that you can control with, you can control with WASD like this, and place things. Well, the editor camera is just where are we looking? It ignores the player position. The editor camera is just like es.camera pos, yeah. But editor update then is what runs the editor, and this thing just it has a global editor state here that the editor state set global. This is run on every hot reload. The state here, editor state, is defined here, but it actually lives inside the game memory here. So even when you hot reload, this thing is part of the game memory, but in game hot reloaded here, it runs editor set globals with this thing so that this global pointer is valid after hot reload. So you have your editor camera, which is just using the camera position in here, for example. And the editor update modifies that camera position depending on the WASD presses here. Then it figures out where in the world are you currently pointing, which is this grid post stuff. It takes the screen mouse position, gets the world position using this get screen to world 2D, which takes a screen position on the camera. And then it figures out the grid position. That's essentially just dividing by the tile size and flooring. And I currently don't have any editing modes in here. So this is all there is to the editor right now. So later there will be a way to place entities. I will also, like currently, in order to change, I have a hotkey to change which index in the palette in the tile set you're using. I will add a palette that you can pick from. Currently don't have that. But this thing just, if you're holding down the left mouse button, then it adds tiles. If that position is not used, oops. If this position is not used, then it adds tiles there. Like you can't add if there's anything there already. It just checks. This is also not very optimized, but we'll see how that goes. It's not. I can fix that if it gets slow. This is just for me, anyways. I fix it if it's broken. If there's no tile at this position, and the grid pos is again just this position here that I calculate based on the mouse cursor, and the t.pos is the tile's current position. If there's nothing under the grid pos, then I add it to the tiles with the tile that is current. The current tile is the one I choose by pressing these. I press the brackets on my keyboard. You see here, right bracket, I increase the tile ID, left bracket I decrease it. And I also clamp it in a reasonable range down here. This code should probably be here, but never mind. But this is how it adds tiles. So it just constructs a tile using the grid position, which tile is currently selected, and flip is if I press the X here, it sort of flips the tile. So I can do stuff like this, right? Right, like that. And if the right mouse button is down, then it just checks if there's anything under the cursor and it removes it from the tiles array. Right and left bracket change with tile. I already talked about that. X flips in X direction. Here it just flips this flag on the editor state, which is used up here when it adds it, but it's also used. The stuff down here is what draws the brush, right? So it takes from the Atlas tiles the current tile, which is the sort of brush one, and it takes a tile, and if it need to flip it, if we're in the flipped mode, then it flips the width of it, and then it just draws using the Atlas that tile at the position where the cursor currently is. World grid position is then again multiplied by tile size. So this is the tile position, which is 0. It is like whole integers, and this one then multiplies by each by 8, so it becomes like as big as it should be in the world. It's not like on a grid anymore. It's more of a, the first tile is at 0, 0, the next one to the right is at x8, y0, for example. So that's the world grid pos. So that's what why it draws it like this. So it draws the draws it in a grid that's snapping around like this. And I can also, this thing here is just, if I hold down left shift while pressing X, it flips the thing under the cursor. That's just so I can do this. I can flip that thing. Yeah. And that's it, I think. And most of, many of these things, like the file version, no, there's not the file version builder, is not in the template. Maybe I should add that, I don't know. But the or maybe it is in the, I don't know, but the Atlas builder is in the template. And all the stuff for the hot reload, which I think is the important stuff really. That it takes a while to write this Atlas builder stuff. Wasn't all that easy actually. Yeah. I don't think I have anything more. I will continue experimenting with fun gameplay things. I have some new ideas for abilities that the player can have, and that will all be it's just fun to experiment around with and stuff. I want to thank my patrons. I have all these patrons which are supporting me on Patreon, and I also have my 2 super supporters which donate like $20 a month to me, and those are Ian Seckington and Player Nathan. Thank you so much for that. So I guess if there's any questions, Davidash Asacella says, thank you for this walkthrough, thank you for watching. Davidash asks, to compile for Linux Mac, can you set the out flag? Well, for Linux and Mac I have separate build scripts. I have build hotreload.sh, which I think very friendly people on my Discord server has given me, has fixed for me, because I do all the development on Windows, so I only had my hot reload stuff for Windows, and then the only thing I had for Linux and Mac was the build release, so I only build release access on those platforms, right? But my friends have added, so the hot reload stuff works on Mac and Linux, and it even works like it checks, it uses DYLib and SO stuff instead of DLL and stuff. These nice people have fixed all that. So you just run these SH files instead to compile on Linux or Mac, and it should all work nicely for you. Yeah. One thing I didn't mention also is I had this world.json, of course, and that thing I need to replace. I have a procedure called save and a procedure called load. The save file just outputs a JSON that is marshaled from the list of tiles, and then the load one loads it back. And it runs save when you quit the editor, and load is run when you start the game. Also, I will change this very soon so that the editor has its own representation of the world that is untouched. That is the original representation, as it should be on the hard drive. It only works with that one, and the game has its own version, so the editor is not editing the game version, because that's very dangerous, because suddenly if an entity starts one position, then you moved it, then you might be changing, by playing the game, you might be changing your level editor data. It's super bad. So this stuff will change, but this is just how I did it in a simple way, just to get some simple serialization going, right? Yeah, that's the last thing I forgot to talk about. I think that's that. And yeah, like I said, thanks to the patrons, and thank you all for watching, and I will keep working on my little Metroidvania-ish game, and we'll see what happens. See you all later, and happy programming. Bye bye.